Hello students, these are your IB Applications Year 1 notes, and this video will go kind of fast, so feel free to pause it whenever you need some time to process. So in the beginning, we're going to review solving quadratic equations, and you may remember from Algebra 2 that there are really three methods for solving quadratic equations. One is factoring, one is quadratic formula, and one is graphing. Okay, so graphing is not a good choice when your answers are irrational because it will just give you a decimal approximation and not an exact answer. But in other cases, you might find graphing to be a good method, and you can find those zeros on your calculator. For today, we're going to start by trying to factor. So remember that when the coefficient of x squared is 1, if it's just 1x squared, it's really a very simple factoring. You're just looking for two numbers that multiply to negative 24 and add to 5. And those numbers, if you can't pull them out of your head right away, you can just start making a list of multiplying to negative 24. Don't forget the negative 1 and 24. Sometimes that's the one you need. Negative 2 and 12, negative 3 and 8, negative 4 and 6, and of course the other number could be negative as well, but in this case we have found the pair that adds to 5, and so you just write your factors. X minus 3 times x plus 8 equals 0, and then the zero product property tells you that if I multiply two things and the answer is 0, one of them has to be 0. So either x minus 3 could equal 0, or x plus 8 could equal 0. And solving those, we get x equals 3 and x equals negative 8. The next one is the difference of squares pattern, and you may remember the difference of squares pattern says if you have a squared minus b squared, that can be factored to be a minus b times a plus b. And to find your a and b, you just find the square root of your two terms. So the square root of x squared is x, and the square root of 225 is 15. So you get x minus 15 times x plus 15 equals 0, and just like the last one, set each equal to 0. This one will give you x equals 15, and this one will give you x equals negative 15. Okay, so in number 3, we're not ready to use the zero product property because we don't have one side as 0. So the very first step is to make this side 0 by subtracting 7 on both sides. And I have 12x squared plus 17x minus 5 equals 0. And now, because my coefficient of x squared is not 1, the method is a little bit longer. You're going to multiply a times c, 12 times negative 5, to get negative 60. And we're going to look for numbers that multiply to negative 60 and add to 17. So I'm going to start my list until I get there. Okay, and I think I found it right there. Now, I can't just write x minus 3 times x plus 20. If you multiply that out again, you will see quickly it does not make 12x squared plus 17x minus 5, but you can use these numbers. So you take these numbers, negative 3 and 20, and you're going to use those as the way to break up 17x. So instead of 17x, we'll write negative 3x plus 20x. And then you'll bring down the 12x squared and the minus 5. And then you group the first two and the last two terms, and you're going to factor out a greatest common factor. So from the first two, I'm going to factor out 3x. When that comes out, I'm left with 4x minus 1 And then these two I can factor out of 5. And we have 4x minus 1. All right, so 4x minus 1 is matching. That means this is going to be one of our factors. And 4x minus 1 is multiplied by 3x. And it's multiplied by 5. And that makes your second factor. And then finally, you set your factors equal to 0. So 4x minus 1 equals 0. Gives me 4x equals 1, and x equals 1/4. 3x plus 5 equals 0 gives me 3x equals negative 5, and then x equals negative 5 over 3. All right, last one. Oops, you couldn't see any of that, sorry. Here we go. Last one, you can see that there is no number in front of x squared, which means it's 1x squared, and it should be the easier method. But there are no numbers that multiply to negative 2 and add to 4. So we're going to try the quadratic formula. You can always look this up if you forget it. Negative b plus or minus the square root b squared minus 4ac over 2a. It can be a little bit tricky on your graphing calculator. Remember that you are going to need to have parentheses to hold together your numerator and parentheses to hold together your denominator. We'll look at that together. All right, so my a is 1, my b is 4, and my c is negative 2. So negative b plus or minus the square root of b squared minus 4ac, b squared minus 4ac over 2a, so just 2 times 1. And actually, I'm not going to put the whole thing into the calculator at once because I'm going to end up with an irrational number, and if I put the whole thing in the calculator at once, it doesn't give me anything better than just graphing. So we're going to try to get our exact answer here by simplifying this radical. So I have negative 4 plus or minus square root. This is going to be 16 minus negative makes plus 8 over 2. Negative 4 plus or minus the square root of 24 over 2. All right, and then 24 can simplify. Remember, 24 is 4 times 6, and the square root of 4 is 2, so that can come out negative 4 plus or minus 2. So I took out the square root of 4, which is 2. I'm still left with a 6 under my square root over 2. And then each of these terms can divide by 2. And so I get negative 2 plus or minus root 6. So that's two different answers, negative 2 plus root 6 and negative 2 minus root 6. All right, moving on to just a little bit of vocabulary. Graph basic quadratics. So these graphs where we have equations in the form of y equals ax squared plus bx plus c, where a, b, and c are any non-zero number, they're called parabolas. That's just the name of the shape of the graph, parabola. So parabolas will always have a y-intercept. They will always cross the y-axis. And this is the point on the graph where it touches the y-axis. We can find it by setting x equal to 0 and finding the value of y, because everywhere on the y-axis, x equals 0. Parabolas or quadratic equations can have 0, 1, or 2 solutions, known as x-intercepts. Roots or zeros. And actually, I would qualify that to say 0, 1, or 2 real solutions. because they never actually have zero solutions. If you see zero x-intercepts, the solutions are just complex solutions. Parabolas have an axis of symmetry. Okay, and you can find the value for the equation. It's going to always be x equals a number because your axis of symmetry is a vertical line. And that number is going to just be the x from your vertex. So if you know what your vertex is, you know where your axis of symmetry is. But if you don't, you can use this little formula, negative b divided by 2 times a. And this is also the midpoint of the x-intercepts if they exist. The point on the parabola, which intersects the axis of symmetry, is called the vertex of the parabola. That's also going to be your absolute maximum or your absolute minimum, depending on if your parabola is facing up or down. The x value of the vertex will be on the axis of symmetry, and we can find the y value by substituting the x into the equation. Parabolas have concavity. If the vertex is the minimum point, then the parabola is concave up. So it would look like this if it's concave up. And if the vertex is a maximum point on the graph, then the parabola is concave down. And it would look like a frowny face, like this. Okay, so parabolas can be transformed in the following ways, starting with the parabola defined as y equals x squared. So that is your parent function there. So it can be vertically, so vertically is left and right. I'm sorry, vertically is up and down, sorry about that. So it can be vertically translated. So that would be if it's moving up or down. By k units, so if you just add to the end, that's going to shift you up or down if you add a negative number. You may have called this also shift. So vertically translated is the same as vertically shifted. And then if you add or subtract inside of the parentheses, then that would horizontally translate. And again, in Algebra 2, you may have called that horizontally shifted. So this way, left and right. If you put a number in front of your x squared besides 1, then you could be vertically dilated. In Algebra 2, you may have called that vertically stretched or compressed. And this one is the same as Algebra 2. If you have a negative in front of your x squared, this one will be vertically reflected. So a lot of vocabulary to get through. Okay, so we are going to graph this quadratic equation by completing the table of values, and you can individually substitute each number into your equation to find the y values, or if you enter it in your y equals, then you can go second table, and we can go back to the values that we want. So we need to start at -3. So I'm going to copy these values into my table. -74, -47, -26, -11, -2, 1, and -2 again. Okay, so you can see on this graph, I'm not going to be able to graph these first 3 points because they're just way off the graph, but I can graph the next set of points. And because the parabola is symmetric, I know that there's going to also be a point at 4, -11, and so I can graph that point as well. And then sketch in my parabola. Okay, so it says, what is the maximum or minimum y value? And you can see that this graph has a maximum value. It goes to negative infinity, so it has no minimum y value, but it has a maximum y value. And that would be here when x is 2, the y is 1. And so the maximum y value is 1. Okay, the axis of symmetry goes through your vertex like this. And since it's a vertical line, it's always going to be an x equals equation. And it's going to be x equals, in this case, 2. All right, so looking at this next function here, it says determine the equation of the axis of symmetry. And we don't know what the vertex is, but we can find the x-coordinate of the vertex by using the formula negative b over 2a. So the axis of symmetry is going to be x equals negative b, negative 4, over 2 times a, which is 1. So that's negative 4 over 2, which is going to give us negative 2. Now, that's going to be the axis of symmetry, but that's also the x-coordinate of your vertex. So to find the minimum value of y, we need to find the y value of the vertex. So we're going to substitute negative 2 into the equation to find the y value of the vertex. Negative 2 squared plus 4 times negative 2 plus 3. And that's going to give me 4 minus 8 plus 3, which is negative 1. All right, and then finally, what are the coordinates of the vertex? Well, we found the x-coordinate is negative 2 and the y-coordinate is negative 1, so we just need to write that as a point. Okay, so here's the graph of another quadratic function. State the coordinates of its vertex so we can look. And then the vertex is at negative 2, negative 1. And then it asks us, what is the relationship between the last one that we were looking at and the graph provided? Well, if you remember, the last one also had a vertex at negative 2, negative 1. So they had the same vertex. And they have the same concavity. They're both concave up because the x squared term is positive. So same concavity. And if you solve this by factoring x plus 3, x plus 1, you would see that they have the same x-intercepts. And so it turns out that they are actually the same equation. All right, number 3 says use your calculator to graph y equals 4x squared minus 64x plus 240 and then answer the following questions. All right, so we're going to graph this on your calculator. It may not fit in our standard window. Let's take a look. I'm not in a standard window right now anyway. Okay, I'm going to hit zoom standard to see how it looks in the standard window. All right, I'm only seeing part of it. You could try to zoom out and see how that works for you. Kind of works. Okay. Or you could also just manually adjust your window. So is the graph concave up or concave down? So you can see that it's opening up, so we say it's concave up. All right, the vertex is down here, and it's hard to tell exactly where it is, but we can try to find that minimum value. We can go to second, calculate, and minimum, which is 3. And it wants a left boundary. So right now it's way up there, but I am to the left of the minimum now, so I'll press enter. And then I have to go to the right of the minimum, and I'll press enter, and then for guess, just enter again. All right, and this number here, it's actually not 7.99998. Sometimes your calculator makes a rounding error. It's exactly 8. So the x is 8 and the y is negative 16, and that's my vertex. Okay. The y-intercept is where the x is 0, so I should be able to get that from the table. So here it is. When x is 0, y is 240. And then it asks, what are the x-intercepts? Now, I might be able to find those from the table, and if I can't find them from the table, then I can try to find them through the calculate menu. So here, 6, 0, that would be 1. And then 10, 0, that would be another 1. Okay, moving on. An object launched from the ground has a height in meters after t seconds that is modeled by the equation y equals negative 4.9 t squared plus 58.8 t. Graph this equation using a calculator and answer the following questions. So we need to find the maximum height. Now I can tell this will have a maximum because the negative indicates it's reflected, and so it's going to have a highest point. I'm going to just try graphing my last window and see how that looks. It's not really good enough. Next thing I can try is zoom fit, which is 0. Okay, it's looking a little bit better. I just want to see a little bit more on the top there, so I'm going to go to window and I'm going to change my Y max to be just a bit bigger. I'm going to try 200 for my Y max and see how that looks. Still not seeing all the way to the top. Try again. From the window, the Y min is so big. Why is my Y min so big? I don't feel like it needs to be. Y min, I'm going to try negative 100. And then let's try that graph again. Oh, beautiful. Okay. All right, what is the maximum height? So I need to find the maximum there. So I'm going to do second, calculate, and maximum, which is choice 4. For the left bound, I could actually press enter right there as long as you're to the left of the maximum. And then right bound, you need to move to the right of the maximum. And then enter, enter. All right, so again, a rounding error here. This one should be 6. This one, though, does look like it's going to be 176.4. So rounding to 3 sig figs, the maximum height would be the y value, which is 176, and 3 sig figs, we'll just leave it that. And what's our unit? Meters. After how many seconds is the object at its maximum height? So time is the x value in this situation, and so that's going to be 6 seconds. Okay, and then after how many seconds does the object reach the ground? So we want to know when it gets back to a height of 0. So I'm going to check my table for this. Second, table, and go down. So it looks like after 12 seconds, it has a height of 0. That means it's reached the ground. Okay, a rectangle is to be constructed with 80 meters of wire. The rectangle will have an area of A equals 40x minus x squared, where x is the length of one side of the rectangle. Using the equation, state the area of the rectangle if one side is 12 meters long. So we're going to substitute 12 into that formula. And if you use your calculator, you should get 336. And let's see, the side is measured in meters, so that means the area will be measured in square meters. B says, graph the equation from the graph, determine the nearest value for the longer side rectangle that has an area of 256 square meters. All right, so we're going to take a look at our table to see when the area will be 256. So I see 256 here when the side is 8, but because it's a parabola, it's going to go up and come back down again. So I'm going to go and see 256, 8, 256, and it's still going up. Now it's coming back down again. And 32, 256. So I had those 2 points, 8, 256, and 32, 256. So it says it wants the longer side rectangle that has this area, so we're going to do this one, the 32, I mean. So that would be 32 meters for the side. Using the graph, what is the greatest possible area of a rectangle that has a perimeter of 80 meters? So we need to find the maximum point. So we need to look at the graph, and in a standard window, I don't see very much. You can try to zoom out or zoom fit maybe. Let's try zoom fit. Let's see how that one works for us. Okay, so you can see part of the parabola over here. I need to see less of these negative y's or even negative x's. I need to see more of the positives. So I'm going to go to window, and for my x max, I'm going to try a 20 so I can see more of those. And then for my y max, actually for my y min, I just don't need to see so much. I'm going to go to negative 100. And then for my y max, I want it twice as big, so let's try 600. And let's graph. Okay, I can almost see, I need to see more x's. So go back to window, and I'm going to change my x max to 40. Graph again, and then we might be able to see our maximum point. Oh, there it is. Okay, so I'm going to do second, calculate maximum, which is 4. I'm to the left, so I can press enter there. Let's move to the right of the maximum and press enter, enter. So a rounding error, this is 20. So it's 20, 400. I'm going to write that point down. Okay, so 20 would be the side length and 400 would be the area. So that would be 400, and remember area is measured in square meters. Using the graph, state the dimensions of the rectangle with the maximum area. So we know that one side is going to be 20, right? So 20 times what would give me that area of 400, and if you divide both sides by 20, you find that the other side is 20 as well. So it would be 20 meters by 20 meters. You might want to differentiate them as length and width. You can do that if you want, 20 meter length, 20 meter width. On the moon, the equation d equals 0.8 t squared is used to approximate the distance an object has fallen after t sections, assuming no air resistance or buoyancy. On Earth, the equation is d equals 4.9 t squared. A rock is thrown from a height of 60 meters on Earth. Solve for t, the time it will take to hit the ground. So we're going to use the Earth formula, this one. I'm going to start by writing it. And we need to find the time, right? Yep. So we're going to put 60 for D. And we're going to solve. So first we'll divide by 4.9. And instead of finding that answer and rounding it, we're just going to use that answer. So I have t squared equals this. And normally when we solve this, we would have a plus or minus square root, but since negative time doesn't make sense in this case, we're just going to do the square root of 60 over 4.9. All right, so that is really close to 3.5 seconds. This is 3 to 3 sig figs. It would be that 9 would round up, so it'd be 3.50 seconds. All right, in B, if a rock is thrown from a height of 60 meters on the moon, solve for the time it will take to reach the ground and give your answer to the nearest second. So we're going to do the same exact thing, and we're just going to use the moon formula this time. All right, so we use the moon formula, and we solve for time, and this time we're getting to 3 sig figs, 8.66 seconds. All right, moving on. In a game of tennis, a ball is mistimed and hit high up into the air. Initially, that would mean when time equals 0, the ball is struck 3.5 meters above the ground and it hits the ground 7 seconds later. It reaches its greatest height 3 seconds after being hit. Determine the coordinates of the ball, of the points labeled A, B, C on the diagram. All right, so A, this is when they started. It's on the y-axis, so the x value will be 0. I'm going to put it here as well, actually. And let's see, it says that it was struck 3.5 meters above the ground, so that's going to be 0, 3.5. Now B, that would be its highest point. So it says it reaches its greatest height 3 seconds after being hit. So I don't know how high it went, but I do know that the x value of the point is 3 seconds. And then we don't actually try to find that vertex, we're just trying to find this x value of it down here. The y value, of course, would be 0. And then for C is over here. It hits the ground 7 seconds later. So the x is 7 and the y is 0. All right, so it says using the form of the parabola y equals a times t minus h squared plus k, where t is the number of seconds after the ball is hit and y is the height of the ball above ground. Determine the value of h. So using transformations, I know that t minus h will shift your parabola to the right, and it has been shifted to the right 3, because I know that the x coordinate of the vertex is 3. So that means that my h value is 3. What I don't know is this one, k. I don't know how much it has been shifted up. So in the next problem, we're going to find k. And here's how we're going to do it. We're going to use this first point. Remember, this was the starting point of the parabola. We're going to substitute that into the equation, and we're going to use 3 for k, and we're going to try to find an algebraic relationship between a and k. So let's use this equation. Y equals a times t minus h squared plus k. We're going to use 3.5 for y. We don't know a, and t is 0, minus h, which is 3, squared, and we don't know k. So negative 3 squared is 9, so I get 3.5 equals 9a plus k. And here's an algebraic relationship between a and k. Now, we can substitute in another point. That was the point where the ball landed when t is 0 and t is 7 and y is 0. And we can find another algebraic relationship between a and k. So we've got, again, starting with this. This time we're going to put 0 for y. Don't know a. We're going to put 7 for t. And h is still 3 plus k. Okay. So 0 equals, this is 4 squared, which is 16a plus k. And then it says to solve for the exact value of a. So we have two linear equations in terms of a and k. So we can solve the system of equations here. We can make them both equal 0, and then if they both equal 0, then we can set them equal to each other. So I'm going to take this first equation, and I'm going to subtract 3.5, so I get 9a plus k minus 3.5. So now this equation equals 0, and this equation equals 0. So now they can equal each other. So I have 9a plus k minus 3.5 equals 16a plus k. So what I might want to do next is subtract the k's on both sides. And I have 9a minus 3.5 equals 16a. So I'm going to subtract 9a on both sides. Negative 3.5 equals 7a. And divide by 7. And I'm going to get negative 0.5. So a is equal to negative half or negative 0.5. So finally, we're going to use this a value to help us figure out the value of k, which is the height that the ball reached. You can use either of your two equations. I'm going to use 0 equals 16a plus k, and I'm going to put negative 0.5 in there. So I get 0 equals negative 8 plus k, and 8 is equal to k. So that means that the greatest height was 8, and I believe our unit was meters. I'm going to check real quick. Yes, so 8 meters is our greatest height.